In this question, we're asked to solve this quadratic equation by factoring. In order to do that, the first step is always to make sure that the equation is set equal to 0 and to make sure that the quadratic polynomial on the left is in standard form like this, where your x terms, you look at the power of your x terms and those go from greatest to least. All right, so let's start by subtracting the 25 from each side here so that we have the right form to start with before we begin factoring. So I'm just subtracting the 25 from both sides, and this is what I get. Now I'm ready to start factoring. I also notice that there's a lead coefficient of 2 on the front x squared term, and that makes this a little more challenging to factor. The first thing you want to do is make sure that all three terms don't have something in common that you can factor out. If so, factor it out and get rid of it by dividing through so that you have a much simpler polynomial to work with. In this case, these three terms don't have anything in common to factor out. So from here, I might also look for special patterns like a perfect square trinomial, or if there's only two terms and there's a minus in between them, it might be a difference of squares. But this doesn't seem to fit any special patterns because 2 is not a perfect square, even though 25 is. The perfect square trinomial would always have a perfect square on the first term and a perfect square on the back term, and it would have to be positive. So no special patterns here, so we're just going to be factoring. Now we can do that with trial and error, or we could do it with the AC method. If your lead coefficient is prime, it's usually pretty easy to do trial and error. So you might start by making your double bubble. And then since 2 can only factor to 2 times 1, we know the first terms have to be 2x and 1x. Next, I would look at the signs. If you have a negative on the last term, that means that you're going to have one of each sign. If it's a positive, you would have the same sign, and then you would look at the middle term to tell what those two signs should be. Because here we have a negative on the last term, we know we have one of each sign in our parentheses, and we're not sure whether to put it in the first set or the second set. So by trial and error, we'll eventually figure out where that should go, where each of those should go. The other thing I want to notice is that this is positive. So the larger number, when we do little smile, big smile, the larger product will be positive. So let's try now taking our 25 and we're going to see all the different ways that we could factor it. Well, we could do 1 times 25. We could do 5 times 5. Okay, and I'm going to try 5 and 5 since the two numbers that are closest are usually, not always, but like very often you'll find that that would be the combination that works. So I always go for those first. And then I do little smile, big smile to see how things are panning out so far. So if I do little smile, I get negative 5x. For my big smile, 2x times 5 is going to give me positive 10x. Now when I add those together, I need to make sure that I get the middle term of positive 5x, right? So I'm looking for this term when I combine my little smile, big smile products, right? Notice that the larger product here is positive, like I was planning I needed or expecting that I would need. And so when I add those together, I do get, positive 10x and negative 5x give me positive 5x. So that matches. And if you want to be really thorough, you could take your two terms and FOIL them back out, multiply them back out, make sure you get your original polynomial. At this point, I'm pretty confident that I've found the correct factoring or factorization here on the left. So now I go to the next step, which is to solve. Now when I go to solve, I want to use the zero factor property. It's also sometimes called the zero product property. I'll just say prop for short, which is basically saying that if you have two things that multiply together and give you a product of 0, then either A could be 0, B could be 0, or maybe both. Okay, so I can take each one of these quantities and set them each equal to 0 and solve for x, and then I'll have my two answers. So most quadratics will have two answers. If it's a perfect square, it'll have just one repeated answer. So since my two factor quantities don't look the same, I know I'm going to have two separate distinct answers here. So I'm going to take the first quantity 2x minus 5 and set that equal to 0 to solve it for x. I will also be taking the other quantity x plus 5 and setting that equal to 0 so that I can solve for x. So I'll just do each one individually. So I'm going to start with the one on the left here. To solve for x, I'm going to first do all my inverse operations. I'll undo the minus 5 so that I get 2x equals 5. Then I'm going to divide both sides by 2. So I'm just undoing the multiplication here so that I get 1x equals 5 halves. And that simplifies to x equals 5 over 2. So that's one of my solutions. Then I can solve the other, subtracting 5 on both sides to zero it out on the left. And I have x equals negative 5. So that's my other solution. So now my solution set is negative 5, comma 5 halves. And depending on if you're doing online homework, they may ask you to put it into set brackets, or they may just say list your answers with a comma in between. So just make sure you're looking at the directions to make sure that when you're entering it, the syntax doesn't give you an error, even though your answers are correct. And also, before entering your answers, it may be a good idea to go ahead and plug them one at a time back into the original equation, the one that you haven't messed with yet, so that there's no possible mistakes in it. If you plug each of your solutions in one by one and make sure you get a true statement both times, then you know for sure that you have the correct solutions.